Hey, and thanks by the way. Today, you and me are gonna build something amazing together, and that's a beautiful, fully functional analytics dashboard from zero to finish. And when I say beautiful, I mean beautiful, man. It has all the details you expect, like little badges to indicate the progress that you're making, even country flags to show you which countries your visitors are coming from. This works for any kind of data, how many people contact you from your portfolio, how many people purchase the Pro plan on your SaaS, anything you can imagine, you can track with the approach I'm gonna show you in this video. You're gonna learn how to write clean APIs that are fun to use and maintain in your project, and as the cherry on top, we're gonna deploy it into a side project I made that has a couple thousand users to show you, hey, this really works reliably. So I really recommend you open your code editor, you follow along. There's so much to learn in this video, and I'm just happy to build with you. Let's get into it. Okay, so let's get started in implementing this. I'm really happy with how it looks. So here's the deal. I'm gonna do this in a new Next.js project on my desktop and not Digit. There we go. If you already have a project where you need an analytics dashboard like this, like your portfolio, an e-commerce website, and so on, go in that project. This is super compatible with any existing project. But just to demonstrate the simplicity of it, I'm gonna do it inside of a new one. So I'm gonna say, and zoom in a bit so you can see this is your npx create next app at latest. We can already give it a name, let's say analytics dashboard, for example, and then hit enter. That's going to ask us a lot of questions, as always, when we create a new app, like if we want to use, TypeScript, Tailwind, CSS, and so on. And to those questions, we're going to say yes, yes to ESLint, yes to Tailwind, yes to the source directory, although that is personal preference, yes to the app router, and no, we do not want to configure the default alias. Perfect. That's going to create the app for us, and by default, it's going to use npm, which I really don't like, to be honest. I don't know why they haven't added an option to change that. But anyways, doesn't matter that much. Let's cd into this project. We called it analytics dashboard. And then we can say code dot to open this project up in VS Code. That's going to open right here on my right-hand side monitor. And bam, there we are, completely new Next.js project. Perfect. First thing we're gonna do is navigate inside our layout.tsx. And by the way, first thing we're gonna do is already start this up. And that's gonna create a development instance in Next.js 14.1. And there we are. Perfect. Okay, so this is the main Next.js page. And first thing we're gonna do is go inside of our layout and do one little change here, because we want to make this a really nice looking, beautiful dark mode. So let's get rid of the default class name in the body, and instead we're gonna insert the inter.class name that was there before inside of this template string syntax right here that allows us to kind of interpolate that value. And we're also gonna add dark, and we're gonna say bg dash, and then in angle brackets for a custom Tailwind value, we're going to say hashtag and then 020817. That's like a pretty dark kind of background that's going to look really nice on our page. We can hit back over, and right now we won't really be able to see that because this page already has a set background. But now comes the part where we're going to start with the analytics. So under the app directory, we're going to create a new folder and call this analytics. There we go. This is a folder, and inside of here a new file called page.tsx. This page is going to contain all the content for, well, the page, right? So from here, this is nothing else than a regular component we can export. So an arrow function component, and export that as the default at the very bottom right here. And now whatever we return from this component, like a paragraph, for example, saying hello world, if we go ahead and save that and then navigate over to /analytics, the route we have just created with this folder, and hit enter, that's going to take us to this page. And now the background looks really bad, and that is probably because we still have some things in our global.css. Let's get rid of all of this. We don't need any of that. It makes our page look horrible. And there we are, right? We have the dark hello world up here, and then this really nice dark blue background. Perfect. And by far the easiest way to get started with this is by starting to track analytics events right away. We're not going to wait for anything. We're just going to create a new file inside of our source folder and call this middleware.ts. Now this, you don't have to track anything in the middleware, right? But the middleware is an option that Next.js gives us, which is so convenient for tracking, and you're going to see exactly why. inside of this middleware file, we're going to say export default async function, and let's call it middleware. And this middleware takes in a rec, a next request, if you're in TypeScript, which I really recommend you follow along with. And here's the deal. Now, you can have any custom tracking logic in here. You can track page visits, you can track the country of people, you can track a lot of things. Just be careful that you're not too invasive. And if you use cookies, then you also notify the users. We're not going to do that. We're going to have some very simple, but still really insightful tracking without any cookie notices. So inside this if statement right here, let's do a little check. If the request.next URL.pathname, and let's actually, we called it rec up here and not the entire request, it's just a bit easier to type. And if that is triple equal to slash, that means the user is currently navigating to the home page. And in that case, we want to count them as a visitor. Right? Now, to make sure that this middleware runs when we expect it to, when the user navigates to the homepage, we also, at the very bottom here, need to export a const matcher. This is just according to the Next.js documentation. I didn't, make that up. We need to do that. And this matcher determines when the middleware will run, on which paths it will run, right? So for example, if we just leave a slash in here, then it means this middleware right up here is going to run when any user navigates to the home page, which is exactly what we want. So in here, we can actually track analytics event. For now, we're just going to console log, let's say track, format the file, save the file just to make sure that the middleware actually runs when we expect it to. So let's reload our page. Right now, it should not run because we are at /analytics, if you remember. And we can see there is no log indicating that it ran. But if we now navigate to the homepage, perfect, we can see track. That means every visit to our homepage will now be tracked, or will in a second be tracked here by our analytics, while any other path like the /analytics will not. Now, of course, you can also change this to run whenever you want. The Next.js has a great middleware documentation. Basically, if you want to run this on more paths than it currently does, then there is this one regex right here where the middleware will run on every request except like to the API routes or to the static images. And then in here, you could check the actual path, like the contact me or the about me and so on. But this is just a really easy way to get started where we just track the homepage. So let's just do that. Let's just track the event, and we're going to do that inside of a try catch block. So if anything goes wrong with the tracking, the user experience is not going to be suffering because we're going to say fail silently. So essentially what this means is if anything goes wrong during the try stage where we are tracking the analytics event, we don't want anything bad to happen. We can certainly log out the error for us to see in the logs, but we don't want to block the request from the middleware in any case. So that is why at the very bottom right here, we're going to say return next response.next and invoke that. And of course, we also need to import this. And there we go, from next/server. So if this fails for any reason, nothing is going to happen to the actual request because tracking analytics is just kind of the cherry on top, right? But if anything goes wrong, we don't really care. And this is the point where we have all the freedom in the world to think about how we want to design our API. How do we want to track an event like analytics.track, for example, because this API doesn't exist yet. We're about to create it, but now is the time to think about how it should work. How should it look when we track an event? And I propose this solution right here, where we have the namespace we want to track, for example, a page view right here in our middleware, and then metadata. This is super important because, for example, we want to track which page did the user visit. If you have multiple pages, this could be the about or just the homepage like this. Or you could even go as far as also including the country of the user. And this is really easy because Next.js gives us access to this. Now, this is not provided by all browsers, especially the very privacy focused ones, but most do. Like Chrome, Safari, Firefox, I think most of them do. So in many cases, we will actually have this data, for example, to see which country the people that visit our website come from. And I think this is a pretty neat API design, right? We have metadata with everything important that we need. We have a namespace to attribute this event to. And now the only thing that's missing is the actual, API design that we are about to implement. So let's do that. And I propose we do that inside of a separate folder in our source directory. And we call this utils, because after all, this is just kind of a utility analytics thing that we have in our project, and all utilities that we want to reuse across our app go in the utils folder. At least that's how I do it, right? This is not set in stone by any means. So let's call this analytics.ts, and let's get to the fun part, the API design. How should this work? And there are multiple ways to go about this. First off, we could do the functional approach, right? Where we have a, by the way, you don't need to follow along right now, I'm just explaining this, where we have like a const analytics, and inside of this analytics, this will return an object containing other functions. Like for example, in here, we could have a function called const track that we can call later to track an event. And then we can return that function track from our analytics. Essentially, all that allows us to do is to say const, and then we can destructure from analytics, invoke that, and now we can destructure the track function wherever we want to call it, right? For example, in our middleware right here, we could do it like this, where we destructure the track and then call it here, like this kind of, but I don't think that's nice API design. I think it looks pretty bad, and the functional approach doesn't really fly here. Instead, what I think is way better is by exporting a class analytics. There we go. And don't worry if you've never worked with classes, this is really not complicated, and the API design is going to be so worth it. So in here, we want to do one thing first, and that is define a private property. Again, if you've never worked with classes, don't worry. If you have any object-oriented background, then this is going to feel super natural to you. We're going to define the retention, because the beautiful thing about the database we're going to be using is we can set a time to live where entries automatically expire. And this is going to be of type number. And let's default this to 60 times 60 times 24 times 7, which is just a week in seconds. So 1 minute, 1 hour, 1 day, and 1 week. That's all it is. And the private just means wherever we instantiate the class. So const analytics is equal to a new analytics, just like this. Wherever we instantiate the class, the analytics dot will not have a retention because we marked it as private, right? If we didn't, it would have the retention right here. But this is just an internal thing that we're going to use inside of the class, and there's no point in polluting our API like this. So that's why we're going to mark it as private. Okay. Now, if we create the class, which just means this, right? This is how we create the class. We also want a constructor to override the retention if we want to. So we can do something like retention is going to be something custom here, right? So we can override the defaults if we want to. And the way we do that is inside of the constructor, which takes a options, which is optional. That's why we put the question mark right here to tell TypeScript, hey, this is optional. We don't have to pass it. And this is going to be of type analytics args, an interface we're about to define. And this will be called when we create the class, right? And then here is our perfect option to first define the analytics args. We need to do that right up here. Let's say type analytics args, and this is just the TypeScript type of whatever we can pass in wherever we instantiate the class. So in our case, this is just gonna be the retention, and this is gonna be optional of type number, just like this. And now is the time to assign the retention, right? If we pass a custom retention in here, like we now can, for example, 3600, which would be in seconds 1 hour, then we could override the internal retention in the constructor. So we can say if the options, which is optional, that's why we have the question mark, dot retention is passed. In that case, we're going to say this dot retention is going to be equal to opts dot retention. So whatever we're passing in as the overriding option, we're going to put as the retention inside of our class. And that's it. Like, classes really are not that hard. The constructor, whenever you instantiate a class, can override internal properties, and these internal properties we can now use across the entire analytics class. Really simple stuff. For example, inside of the async track function, the main function we're going to have inside of our app, right? So now you can see if we instantiate the analytics anywhere, we can even go ahead and export this right now so we can use it in other files. if we now try to use this anywhere, analytics.track. How cool is that? This looks really nice. This is some good API design. And the track function is going to be so much easier than you think, because essentially all we are going to do in here is a database call to persist this, what do we call it? This event, right? So we get an event that we track right in here. And this is going to contain, for example, the namespace. This is going to be a string. And by the way, the namespace is just a fancy word for kind of the event name. If you remember page view, for example, this could be the contact me. If somebody pressed the contact me button on your portfolio, whatever, this can be anything you want. Really, that's just the namespace. We also want to receive the event. This is going to be an object, and let's default that to an empty object. So this is going to be kind of the metadata, or we're going to call it the event. And then also some options, which are optional, but actually let's get to that later. We're not going to worry about that for now. For now, let's just create a database call to persist this. This is just one line of code. This is incredibly easy, but currently we don't even have a database. And this is where we're going to create our database. Let's go to upstash.com. By the way, this is not sponsored. I do work for Upstash, but this is not sponsored. They don't know I'm making this video. You can use any other database you want, especially NoSQL like MongoDB might go pretty well with this. But the reason we're using Upstash is because it's really easy to get set up, and they also have the time to live, right? Where we can expire entries after a certain time, and they're super fast because it's Redis. It's an in-memory data store. So there's a lot of advantages to using Upstash, but again, not sponsored. You can use any other option that you want. Great. Okay, now inside of here, we're gonna define a name for our data. Oh, by the way, I clicked on the create database under Redis right here. This is where we are. And this is where we're going to create our database. Let's say analytics YT for YouTube. Anyways, I'm going to select Frankfurt as the region, and we can enable the TLS. This is really just optional. It doesn't make a difference for our use case at all, but essentially this will just encrypt the data traffic. And just like that, we have our database. Perfect. We can go ahead and click JavaScript right here. And after making these visible, we can simply go ahead and copy this JavaScript right here and create a new folder inside of our source folder and call it lib. The lib folder usually contains files like redis.ts in which we prepare libraries to be used in our project. For example, Redis, which comes from a library that is Upstash Redis, or the other database that you're using, depends on how you're following along. And we're going to say pnpm install, not track, but add upstash/Redis. Did I use pnpm for this? No, we are using the regular npm, so let's just stay with that. npm install add upstash/Redis. And that's going to make it super easy to connect to our database. Now, we do not want the token like this right here. This is really bad in terms of security. So instead, what we're going to do is move this token over into a .env file. Like this. The env file, let's name it redis_key is equal to, and then the token we just cut out. The env file contains secure tokens that we do not want hard-coded in our code, and essentially allows us to do something like this. So for the token, we're going to say process.env.redis_key, whatever we just named this env variable right here. And we're also going to put an exclamation point at the end to tell TypeScript, hey, we are sure that this will exist because we just defined it. Okay. And we can now export our const Redis for our database. And just like that, we can already get started in tracking the analytics. You remember the track function right here. We can now simply call await Redis and import that from our lib folder. And there's so many commands we can choose from. In our case, we're going to use the h-inc by. So the hash increment by. That's what it means, and you're going to see visually what this does in a second here. And we're going to increment the key. So how this works is we provide a key, a field, and then the incrementation by. In our case, that's going to be 1 because the event happened one time when you call this function. Now, we also need to provide a key, or if you're using SQL, for example, that would be the table name where you want to save this. And let's say const key is going to be equal to, and let's say analytics : So we can name this anything we want, but I think this is a good database kind of structure to put it in. and then interpolate the namespace right here, namespace. So this is going to be analytics : page view, for example. And then we can increment that, add the key right here. We can pass it the metadata, and we're going to stringify that, json.stringify the event, and we're going to increment by 1 because the event happened once. And you're going to see that this approach right here with the stringification of the metadata has a huge advantage, and we're going to see that later. For now, let's import the analytics in our middleware, save the files, and this should already start tracking. And of course, we need to start the server back up, right? But after we got that all set up and started back up the development server, if we now navigate to our home page, then we should see an entry in our database that says that this was tracked successfully. So we're at the home page. Let's go into our data browser right here, and we can see beautiful, there is our page view. If we give this a bit more space, we can see the stringified metadata of where this event occurred and then the amount of times this happened. So if people started going to our homepage right now, we see that in our database. If we refresh the page, there we go, 4 people have visited our page today. Beautiful. And with the stringified metadata, again, this is going to become really useful later. And if you're wondering why the country is not here, that's because we are in local development and it is not passed in local development. But when we deploy this, this will actually start showing the country here as well. Now you might be wondering, Josh, where is the date in all of this? Because essentially what I showed you in the very beginning, this console right here, let's refresh this. Did the visitors increase? Yeah, they did. Hey, this is kind of cool. Anyways, what I mean is this is by day, right? Visitors today, average visitors per day, and so on. And in our current data structure, we do not have anything that reflects the current date. This would be like completely persistent, right? There is no date involved in all of this. So we need to find a way to incorporate the date. And to show you how this works, let's quickly take a look at the data structure. Let's zoom out just a bit so the tooling is going to be smaller. There we go. Let's take a look at the data structure that we're going to use, because it's very straightforward. Essentially, the days are going to be super important. Let's leave them at the top right here. And then for each day, there is going to be a bunch of events. This can be a page view. This can be a contact me action in your portfolio. This can be whatever you want to be an event and later show in the dashboard. A purchase in your online shop, for example. So for each day, they will have multiple events, where each event is basically just the stringified metadata, like the page is gonna be the home page, as you just saw, and then the count right here, the one of how many times this event happened with this metadata, which is really smart to keep as a data structure, by the way, because if more people visit our page, we don't need to fetch more data, but this number just gets incremented, right? If a lot of people visit our page, the data fetching time to get this will always be the same, because just the number is increasing and not actually the amount of columns or rows, which makes the data retrieval really fast. Anyways, how do we get the days in here to have this kind of structure? Right now, we only have the events. And the solution is really easy, actually. We do that right here in our analytics, in our track function. Because right now what we're doing is we're always persisting this information. The time to live, if you quickly take a look at this, is forever for this entry. And this is good. We can have this as a separate option, but normally we want to incorporate the day into this. So to make the current way of storing data an option, let's create an opts object, which is optional right here, that the track function takes. And this is going to be of type track options. Now, this is going to be a super simple type. We're going to define track options at the very top right here. And this is going to contain a persist, which is also optional, of Boolean. Now, in doing this, we can simply say, after defining the key and changing the const to a let, because we're about to mutate this, we can say, if there is no options.persist, that means the data should be in a time series with a day. Otherwise, we're going to store it as right now, where the time to live is forever. But if we do not want to persist the data, so it expires after a week, we can say the key is plus equal to the to like a template string. And then here we're going to say colon, colon, and then we need a way to get the current day, right? And we're going to say get date as a utility function that helps us achieve this. This utility function get date doesn't quite exist, but it's super simple. We're going to create it also inside of a utils folder. And then let's create an index.ts file where like small utilities go that we reuse across the entire project. Let's export a const get date from right here. This takes a sub, which is going to be a number, and let's default that to 0, because this will also allow us to get the date of yesterday and 2 days ago and 3 days ago and so on. So we can fetch the data right here. Imagine this is today, so that we can also fetch the data from yesterday and 2 days ago and 3 days ago and so on. That is why this function will be so helpful. And in order to achieve this, we could completely implement this ourselves, but just to make our life a bit easier, we're going to say npm install date-fns, date functions. This is a utility library for JavaScript/TypeScript that allows us to import one really handy function, or rather two actually, and that is going to be format. And this is also going to be sub days from date fns. And sub days literally does what it says on the can, right? We can say const date x days ago is going to be equal to sub days. There we go. And we're going to subtract from today, so a new date, the sub value that we passed into this function right above. And then we're simply going to return the format function, which allows us to put this JavaScript ugly date instead of a human readable format. And the const that we're going to format is the first argument, and the format is going to be the second. So this is going to be dd/mm uppercase, by the way, /yyyy. So date, month, year. This is the format we want it in. If you want a different one, that's totally up to you. This is how our data is later going to be rendered inside of our table, inside of our analytics dashboard. And now we can already get started. And we exported that. So now we should be able to import this function from our utils. And by the way, for me right now, the auto import doesn't work. If that ever happens to you, restart your window using Control-Shift-N-P. You can open up this menu, and afterwards the auto imports usually fix themselves. And okay, wow, right now they don't. So we need to import this manually, but most of the time it works. Let's say import whatever from add/utils, and this is going to be get date. Perfect. So this allows us to get the current day, for example, today, yesterday, and so on, by just passing in a number. So this would be yesterday, 2 days ago, 3 days ago, 4 days ago. And without putting anything here, we are going to get today. And now to actually delete entries from our database after some time, after the retention time, we can say if there is no options.persist, in that case, we want to await redis.expire, and we're going to expire the same key. That's how it knows which entry in the database it should delete after the time to live. And then we need to pass the amount of seconds, which is going to be this.retention, the value we set up here, or that we overridden wherever we instantiated the class, just like this. And I think I just voice correct. Where we instantiate the class, right? And this is how we can tell Redis to automatically delete that entry from our database after a while. Therefore, right now, what we expect to happen is if we go to localhost 3000 and refresh the page, and by the way, I think we need to start back up our development server for that to even work. What we expect to happen is because we did not pass a persist option, we now should see a second entry in our Redis database that has a time to live of what we specified up here, right? Of like a week, basically. And it should also have the date attached to it, so we can then later show it inside of the graph. Let's reload our page and let's see what happens. There it is. There is the entry in our database. Beautiful. We can see the date is in here and everything else is basically the same. But this allows us to already get started in displaying the data in a beautiful dashboard. That's what we're going to get started with right now. And that's going to happen right here in our analytics page, if you remember, because we in Next.js, I think from 13 on, can define this as an asynchronous React server component, which allows us to do top-level data fetching. For example, let's say the const page views are going to be equal to, and then await analytics And this is where currently we're lacking, right? We only have one track function. And now, once again, is the time to design our API. How do we want to retrieve data from our analytics? Not ingest it, but get data. And I think the good idea to do this is to call it retrieve days, because we're going to get a time series data. And let's say, for example, we want the page view, the namespace. And then we also want to retrieve the amount of days, for example, like the last 2 days. I think this is a pretty intuitive API design that of course doesn't exist yet, but it seems really easy to use. And we can even go one step back for now and just call it retrieve. So retrieve days will get multiple days, and just the retrieve will just get 1 day. So it doesn't even need the second argument, right? This looks incredibly simple, and I really like this API design. Therefore, let's implement it. We can simply do the same thing as with our track function, which is already done, by the way, and create a new function. Let's call it retrieve, because we're gonna get data from our database, and this is gonna take a namespace. This is gonna be not a string, this is gonna be a string. There we go. And inside of this retrieve function, we are gonna just get data from our database. Let's say const res is gonna be equal to await redis dot, and then there's a really cool command called hgetAll, because for each page that we visit, this metadata could change. We are batching and grouping it inside of here, but there could be multiple entries right here with different metadata attached to it. For example, if the country was different, then there would be multiple entries right here. And we can simply get all of them from the hash with the hgetAll right here. Let's invoke this and give it the key where we want to get the data. This is going to be the analytics : then from the namespace, and lastly from the current date, right? The retrieval is always for one specific day, which also means that we need to pass in the date. And this is going to be just a string of where we want to retrieve our data, right? And if we take a look at the TypeScript type of the response, we can see it's a string unknown record, basically an object, right? And that's not perfect because we know the type, and this is going to be a string. So we can kind of override it by passing in a generic to the hgetAll. And inside of here, we can say record string string, for example, to get better typing. And now all that's left to do is simply return the data from our retrieve function that we can then use in our page right up here, right? So data actually comes back here. And the data structure I find really nice for this is to first return the date. And then for each date, if you remember, we have separate events, right? So there's the overarching day, and then there's events for that day. Day is our date. And the events for that date are going to be the object.entries, entries from the response object. And we can simply iterate over them. By the way, the res could be null. So if it is, then we're going to iterate over an empty array, just so TypeScript is happy and we won't get any runtime errors. And we can map over them and directly destructure the key and the value of the current object that we are iterating over. And inside of here, we can simply, we could even directly return by wrapping this in parentheses. And inside of here, we can simply return the key, and that is gonna be the value, but converted to a number. Now, if you're a very beginner in code, then this might seem a bit fast, but essentially what we're doing is if we have a key value pair inside of a object, right? This is a JavaScript object. Let's also add that curly brace right here. And let's say we had 2 of these, then key 2 is going to be value 2, for example. Then what we just did with the object entries.map key value, essentially, in the first iteration, this is going to be the key right here, and this is going to be the value right here. So the key is going to be literally a key, what you can see right here, and the value is going to be value. Now, it doesn't have to be named this way. This could be name John, for example, right? If this is part of our object, then the key would be name, the value would be John, and we are returning the key, so it stays the exact same, which is name, and then converting the value, in our case John, that doesn't make sense, but for example, if this was a string 6, converting that to a number right here. You're gonna see exactly what this does when we log it out here in a second. Anyways, this already allows us to retrieve the data from our React server component as long as we pass the date. So in our case, this is going to be the 11/02/2024. 11/02/2024. Don't worry, we're not going to hard code that later, of course. But for now, we should be able to just render out the page view content that we got from our database, right? The page view, and we can even JSON.stringify that data to show it right here in our dashboard already. So if we navigate it over to localhost 3000/analytics, it should fetch the data from our database. And then it's kind of hard to read because the text is black, but it should show the data from our database with all the metadata attached to it. Perfect. And then the date on which these events occurred. Beautiful. This works exactly as we need it, because that is the perfect basis for a time series analytics, where we can display for each day how many visitors we have, how many people contact you through the portfolio, and that sort of stuff, right? Perfect. This is really, really nice. And we can even make this easier for ourselves. Right now we can receive or retrieve data for one certain day. How about we write a quick utility function that lets us fetch multiple days, right? This is going to be super helpful, especially in our time series dashboard. So let's just call this retrieve days. And this is going to take a namespace very similar to our retrieve, which is going to be a string. And it's going to take an n days, which is going to be a number. The number of days, how many days do you want to fetch for? Last 7 days, last 30 days, last 2 days, whatever you want. And then here we're going to do some magic, because this is going to contain a for loop. And we're going to construct, let's name this I, by the way, for index. And we are going to construct an array of promises that we can simultaneously execute. Because here's the deal. Here's why we're doing this. So the retrieve days function right here. What we could do is send a bunch of requests to our backend, like Redis in our case, or SQL database, whatever you want, for each day, right? Let's say we have retrieve days 7, right? We could make 7 requests for Redis just like this and await each one of them, right? We would await this call and then wait for the second, third. But the thing is, if we pass a lot of days, this is going to take really long. And what we are about to do is do all of these at the same time. So essentially, the entire answer will always just take like one request duration, right? Because all of these are fired at the exact same time, and we can achieve that by forming an array of promises right here. Let's say const promises is gonna be an empty array. And because we're in TypeScript, we also need to define the type of this array. And we know the type because this type is nothing else than what this function returns. Because what we're going to do in the retrieve days is simply call the retrieve for each day. That's it. It's a really simple helper function that we write for ourselves. So we know the type. The type analytics promise that we get from the retrieve function right here is simply equal to the return type, which is a TypeScript utility type, which lets us infer whatever this function right here returns. The return type of the type of analytics.retrieve, right? This is really cool. And now we can put the type right here and say this is an array of it, because there are going to be multiple retrieve calls that we're going to do. Just like that, we can now go ahead and actually go into the for loop. And for each of the n days that we have, we can get rid of the dot length right here. We want to add one promise to our array, basically one retrieval that we want to fire against our database at the same time. To achieve this, we first need the formatted date, so it matches what we expect right here in our retrieve function. So the formatted date is going to be equal to the get date and then simply I at the index, right? For index 0, this is going to be today, and for if this was 2, then it would be yesterday and 2 days ago, and so on. For each iteration of the for loop, that's it. And the const promise that we're going to add to our array is simply going to be analytics.retrieve. And we're going to say namespace and also the formatted date. Now notice we are not awaiting this, right? We want the promise and not execute it right here. So that, by the way, we also need to add that to our array by saying promises.push promise. So now we're adding this into our array up here. And now we can execute all of these calls at the exact same time. Let's say fetched, const fetch is going to be equal to await promise.all, and this is going to be our promises. So right now we're making all the database calls at the exact same time. So the entire duration is basically the length of just one. This is really cool. And once we have that data back, we can go ahead and sort it because we have multiple days, if you remember right here. And of course, we want this to be in the correct order. So that is why we can say const data is going to be equal to fetched.sort. And for each a and b that we get inside of the sort function, which is nothing else than an iterator for the current and the next element that we have, we can do a check. If one date is larger than the other, we want to move it to the right in the array. And to do this, we can simply parse from datefns the a.date, because if you remember, this is actually a string now. This is like the what we have in our database, the 11/02/2024 as a string. So we need to parse it back into a date to actually make it comparable. So we also need to tell datefns the format this is in, which is date, month, year, if you remember, and the basis is going to be a new date, which is just today. And essentially what we are doing is parsing this back into a JavaScript date that we can now compare to the other date, which is larger to, we can simply copy and paste this over to the b.date. And if this evaluates to true, in that case, we can return 1, and else we can return -1, just like that. And of course, we need to return -1, and then the fetch.sort is happy, which always expects either a 1, a 0, or a -1, and just any kind of number to indicate if we want to move this forward or backward in the array. And after sorting our data in the correct kind of days, we can simply return the data from our retrieve days function. So this is the beauty of it. We're using already existing pieces, and this is the beauty of our retrieval function. We're using already existing pieces of our code and just make them easier to use and add one certain functionality, in our case the fetching of multiple days, and extend on what we already built, which is absolutely beautiful, because now what that allows us to do is to actually build out the dashboard and render out this data, because we know it works, right? We can go to our page, put this into a side-by-side, and now the only thing we need to do to get our time series data is to say retrieve days, and for example, we want to receive or retrieve for the last 2 days. And there we go. There is our data for the last 2 days grouped by the date and empty events if there were no events on that certain date. Of course, we didn't track yesterday because we just wrote the code, right? So there won't be any data for it, but that's why there's an empty array for the events. That is handled too. So let's make this beautiful. Let's create a div right here in the return statement, and this div is gonna get a class name of minimum height screen, of width full, of padding y12, flex, a justify dash center, and an items dash center. And inside of this div, we're going to create one more with a class name of relative, a width of full, a maximum width of 6xl, an mx of auto, and a text of white. And inside of this div, we're going to create a custom analytics dashboard component. The reason being that we want this to be rendered on the client side and the data fetching to happen on the server side. The idea behind it is very simple. It's the model view controller. Model, we also have the view, and we also have the controller. Essentially, the model is responsible for fetching data. This is our analytics provider. The controller is responsible for processing data, which is just going to be our page right here, and the view is just responsible for rendering whatever the controller gives it, which is going to be our analytics dashboard, the view. This analytics dashboard does not know anything about where the data comes from or how it is processed, making it super independent. This is something we used at my previous job. This is actually something you're going to see in the wild because it's a very nice data fetching pattern. Okay, for this analytics dashboard, let's quickly create a new folder called components, and inside of here create an analytics dashboard.tsx component. And once again, this is just a super basic arrow function that we can export default analytics dashboard at the very bottom. Beautiful. Inside of here, let's return a div at the very top level. And what the hell is VS Code doing? Just a div element, man. All right. And this div element is going to get a class name of flex, flex-call, and a gap of 6. Now, inside of this div element, one more div element with a class name of grid, a width of full, an mx auto, a grid calls of 1. On small devices, a grid calls of 2. And this really depends on how many kind of cards you want to show next to each other. We're going to leave it at 2 for now, and a gap of 6. Now, inside of this div, we're going to make use of a component that we are going to get provided by our charting library that we're going to use for this. And this is going to be npm install at tremor/react. This is a really convenient library we can use for all the graphs. Tremor React. Let's pull up their documentation right here, because there's one thing we need to get set up. What is happening here? Okay. Anyways, we can go to the documentation on tremor.so, and I believe this is where, yeah, right here, they show the Tailwind config changes that we need to make. So let's pull this up side by side, and while this is installing our package, we can already get started in configuring the Tailwind stuff, so this looks amazing. And this is going to be just two things really: the path to our Tremor module, the node modules, so it can use Tailwind because it's fully compatible with Tailwind. Then it is this part right here, the theme. We can just copy all of this down. I think this is where it should end, right here before the save list, and just paste that as our theme. Just go ahead, paste that in, and now we still need the colors right here. And these come, if we take a look at the very top, from Tailwind/colors. We can simply copy that over as well, paste it at the very top, just like this, and there we go. The errors are gone, and it should have installed our package in the meantime. Perfect. Let's say yarn dev to start this back up. And that's really all that is necessary to get set up with Tremor. There's some other things we could install right here that it recommends, but we don't need that for our use case at least. And you're going to see that. So inside of the analytics dashboard, let's create a card component from Tremor React. And here's the thing. This component needs to be a use client component, because that's what Tremor expects us, right? This can't be rendered on the server. So let's add the use client directive at the very top and give this card a class name. And this is going to be a width of full, an mx of auto, and a maximum width of xs for extra small. And inside of here, we can say, for example, instead of a p tag, average visitors per day. That's what I did in the demo that I showed you at the very beginning. And this is going to get a class name of text-tremor-default, and also a text dark tremor content, which are basically just some predefined colors that look pretty neat out of the box. Let's save that, and let's go ahead over into our localhost 3000 right here. Did we start that back up, by the way? We did. Perfect. So we should be able to reload this page and then already see the card we have created right here. And we don't. So why do we not see the card? We can get rid of a lot of this stuff, by the way. Redis, env, globals. Oh, because we never actually imported the component in our page.tsx. All right, let's fix that. And there it is. There is our card. That looks absolutely great. And just below the p tag we have created right here, let's give this a bit more space, we can create one more p tag, and this is going to get a class name of text3xl, a text dark tremor content strong, and a font dash semi bold. This is going to contain the average visitors per day, so let's call it avg, average visitors per day. And again, this is the model view controller pattern. So our view does not know where this value comes from, the model, or how it is calculated, the controller. It just cares about displaying this. So to make this happen, we are going to define some props for our analytics dashboard component. And let's call this the analytics dashboard props. I know, super original name. And the interface, and then whatever we just called this, the analytics dashboard props, we can define it right up here. And for example, the average visitors per day. And this is going to be a string actually. And you're going to see why this is going to be a string in a bit. Basically, so we can kind of limit the amount of after the comma numbers, so it doesn't look completely horrible. And then we can receive that as a prop and simply render it out. So the view doesn't care about where the data comes from. And we are now expected it to pass this data from our page.tsx. Now, how do we know the average visitors per day? And that is pretty easy. Let's first define a const tracking underscore days. And I'm doing this in all caps to indicate that this is a fixed value, a hard-coded value, like for example 7. So we always get the data of the last week, because this is in days, because that allows us to not only get all the page views, but now divide them by the amount of days to get the average amount of page views or visitors per day. And to do this, we first need the amount of page views. And if you take a look at the data structure of one page view, we can see it has a date, a string, and this date has events. And basically, we want to get all the events for all the days. And for all the events, we just care about this number and adding all those numbers up together. So we basically have one really long array of events, and we only care about the number for each one. Like, for example, the 4 right here. For all of days and all of events for each day, we want to add them up. So kind of like a nested for loop, you can imagine it. But there is actually syntactic sugar we can use to do this. Let's say const total page views, and this is going to be equal to page views, and let's call it page views because it is multiple dot reduce. The reduce is actually like a for loop. Pretty similar, right? It's not the exact same thing, but here's the thing. If we use filter, for example, then the structure of the return is going to be the same as the array we apply the filter on. If we use the map, then the structure can be different, but the length is going to be the same as the original array that we applied on. Whereas with the reduce, we can basically return something that is shorter in length and also different in structure, but we still have the opportunity to map over every item in the array. So it's very similar to a for loop in that we can completely modify everything we want, but just kind of syntactic sugar above it. And the reduce always takes the accumulator and the current value that we iterate over. And we can simply return from here, return the following. That is going to be the accumulator plus the current dot. If you remember the events, we only care about the events inside of here for each day. So basically we are inside of one day right now. If I pull this up right here, this is where we are in one day, and we only care about the events and the number, like 4, 5, 6 of times that this event occurred. So we're going to do a nested reduce. So now we're in that particular day. This also gets the accumulator and the current value. And from here, we can simply return the accumulator plus the object dot values from current at the index of 0 and tell TypeScript that this exists using this exclamation point. And the only thing to get rid of the error is to give this a default value of 0. Same thing, by the way, for the above reduction. So what we just did is we went into each day, then we went into each event right here. For each event, we are executing this code right here. So for example, this is one event, and we have 0 as the default value right here, and then we're adding the value of the object, like the 4, and if there were multiple events like this, then we would also add the number right here, and we do that for all days, eventually leaving us with one single number, and that is the total amount of page views that we can now very easily use to calculate the average visitors per day. This is nothing else than the total page views divided by the tracking underscore days. And let's also say to fixed 1. So there's never more than one number after the comma. And just like that, we have the average visitors per day as a string, by the way, because that's what the toFixed does. By default, this is going to be a number, but the toFixed makes this a string. That is why we also typed it as a string right here in our analytics dashboard. And if we save all of this, then we should see that in our dashboard, we can now see the average visitors per day actually show up over the last 7 days. How cool is that? And by the way, we probably want to enter the tracking days right here, just so we don't mess anything up and don't have the same number in multiple places. But if we want less or more days to track, then we only need to change this number right here. Now, how do we get the amount of visitors that we have just today? And the answer is really easy because we designed our API to be extremely extensible, and we have all the control right here in our controller on the page, right? This comes from the model. We're processing it in the controller. How do we get the amount of visitors? Oops, visitors. Geez, man, English is not my first language, okay? Amount of visitors today. This is going to be equal to page views dot, and now we can only apply the reduction from above on today. So first off, we're only going to apply it to the current day, and we already have a utility to do that. So we're going to say dot filter, and for each event that we get in the dot filter, we can simply return the ev dot date is triple equal to the get date or custom utility function that we wrote, which is going to default to today if we don't pass any number like yesterday, 2 days ago, 3 days ago, and so on. By default, it's today. And now we only have the events that happened today and can apply the reduction on that with the accumulator in the current value. And from here, we can simply return the accumulator plus the current.events.reduce, just like before, that also get the accumulator and current value. And we can return the accumulator plus the object.values of current or current event that we're on. So this is the key, this is the value. We only care about the value at the index of 0. And we can tell TypeScript, yes, we are sure that this exists using this exclamation point. And we're going to start this off as 0 because the reduction also always needs a default value, just like this. So just like that, we are doing a nested reduction. Again, for each event, we only care about the value and add all those values up together just for today. And that's what the amount of visitors today is. It's nothing more than that. We can pass this as a prop into our analytics dashboard as well. And of course, we need to receive it as a number here. We're not going to worry about the toFixed because this will always be an integer. There is no half visitor, so we don't need to handle that edge case. And we can destructure that as a prop and also render it out as a separate card. For example, we can copy this already existing card down using Shift, Alt, and arrow down. And we can simply call this something different. Like we can say visitors today, for example. Oops, and then we can put the amount of visitors today right here. Let's go back into our dashboard and we can see the amount of visitors today is 4. Beautiful. If we refresh this, we get the freshest data. If we go to our homepage, we expect this to go up by 1. So if we go back to our analytics page, then we should see 5 visitors today, and the average visitors per day is now 5 divided by 7. So it's a bit higher. But this is only going to become accurate as you have been tracking for the duration of the tracking days. So after you've been tracking for 1 week, this is actually going to be accurate because right now it also factors in the days where we did not track yet, which is the just empty event array from earlier, if you remember. How cool is that? You have working analytics on your own page now. And this could be anything, any action that you want. As we discussed earlier, this doesn't have to be the page view. This could be like the contact me, for example. This could be the somebody purchased something action. This is what you define. You can track whichever event you want. That is why this API is so flexible. It gives you the full control over what you are tracking on your website to then render it out in the exact same logic right here. So I'm gonna leave it at this right here, but I do remember that I showed you like the average exports per day and exports today. It's the exact same thing. How I did that is literally just copy this down, change this to export, and then remember to track the export just like in our middleware, where we track the page view. It's the literally same thing. So that would just be wasting your time right here. Let's instead work on this really cool graph right here that visually shows how many people visited our page each day. It is much more interesting, and it's also incredibly easy because all we need to do is pass the time series page views into our analytics dashboard. And this is nothing else than the page views. I just decided to rename it into time series because, you know, there are multiple dates involved in this. Anyways, we need to receive that in our analytics dashboard. And to make that happen, we're going to use some TypeScript magic Because the type of the time series page views is gonna be the awaited return type. These both are utility types that TypeScript provides to us. And this is gonna be the type of analytics, analytics, and import that dot retrieve days, right? This way we don't need to kind of copy over the type, because we could just hover over this and copy this over, but we can also just get the type from where we get the data in the first place and just use that right here. Much more reusable, much more maintainable. It's a much nicer approach overall. And then we can simply render out the chart. It's as easy as that. So for example, with one closing div to go, let's enter a new card right here. And inside of here, we're gonna do a check. If we have the time series page views, and I think we forgot to take that in as a prop in our component. Yes, we did. We also need to get access to that value, of course. And if we have that, then we're gonna render something out, and else we're gonna render out null because we don't have the data yet. But if we do, in that case, we're gonna render out a bar chart from Tremor React. Just like that, we can say allow decimals is gonna be false. We only want entire values. We're gonna say show animation to animate this beautifully. And we also need to pass in the data into our bar chart. By the way, this can be self-closing. There's nothing inside of there. And this data is gonna be our time series page views dot map. And for each day that we have, right, if I pull up this right here, for each day that we have, we want the events to be shown in the chart. Therefore, the operation, you already know the drill by now. We can simply directly return an object from here where the name is the day.date. And then the, let's call it visitors with an uppercase V, because this is how it's going to be displayed in our table. So it looks nicer. This is going to be the day.events.reduce. And now we only care about the count, the value of each event. And you know the reduction by now. It's the accumulator, the current value that we're iterating over, just like a for loop. And then we're going to return the accumulator plus the object.values of current at the index of 0. Tell TypeScript, yes, we know this exists, because otherwise it would just complain. And we're going to start the reduction at 0. Perfect. Now, why is this still complaining? Missing the category. Oh, okay, because it's still missing two things right here, which is the categories. This is an array, and this needs to match what we want to display in the chart. For example, visitors, and also the index. And let's just say this is going to be name. So if we now pull up our dashboard and go ahead and save that, let's see what happens. Let's reload our analytics. And is the dev server running? Yes, it is. There is our chart, but it's not showing anything. Oh, and I think it's just because of a typo. I entered visitory, and if we put visitors right here, then we are gonna see the data, but the graph is black. Aha, and after some amount of debugging, I realized that there is another thing in Tremor that we need to copy over into our Tailwind config, and that is right here, this part that we forgot to paste, which is the save list. And if we go ahead and paste this in right here, right above our plugins in the Tailwind config, then it is actually going to show the correct color of the graph. How cool is that? Just like that, we can get beautiful graphs for the analytics to kind of visualize over the days or over the weeks even, right? If you wanted to, how the traffic to our website changed. All right, and as a little bonus, I'm gonna show you how I did this section right here, the weekly top visitors, and then with the countries and their respective flags. And I didn't hard code these flags, by the way. These are dynamic based on which countries are currently the top ones. So as a bonus, I'm gonna show you that and how to do it as well, because it's pretty straightforward, honestly. So if you remember, in our middleware, we are already tracking the country. This will only work in production because in local we won't get the country, but the data will be there, and the data will be stored right here as part of our metadata in our database, right here next to the page. There's going to be like, imagine it like this, the page, and let's just kind of change this, the page, and we're also going to have the country, and this is going to be, for example, DE or FR or whatever the country is going to be. In production, this is what the data will look like. Now it's truncated, but you get the point, right? We already have the data. That means we can already process the data and then show it in our analytics dashboard. To do that, let's create a top countries map. And this map is going to be a new map, a data type in JavaScript we can just use like that with a string, and each string is going to map to a number. So this is going to be the country code, and this is going to be how many people visited from that country. Okay, and now the process is going to be pretty straightforward. Let's do a for loop right here. And this is cool because the way in which we fetch the data or page views allows us to process the data however we want. There is no opinion there. And I really, really like that API design. So, and we're going to iterate over each page view in here. And then the day, const day, is going to be the page view at the index of I, right? So if we take a look at our data structure for each day, right, we want to have each event in the for loop. So TypeScript is actually going to complain. No, but it should complain. Let's set something in our TS config right here. And that's going to be the no unchecked index access is going to be true. That is a TypeScript property you want always on, because it ensures that this actually could be undefined. If the index was like 9999, this wouldn't exist, but TypeScript without that option would not actually catch it. So if we have no day, let's continue. And this is just to avoid runtime errors, right? We don't want any problems at runtime, so we can just handle the case right away. And we're going to do a second for loop in here. Let's call the iterator J, not justify. And this is going to be for each day.events.next. So for each event in each day. So a nested kind of for loop. We're not going to go any more nested. Don't worry about it. This is the all the way we're going to go. And this is the day.events at the index of J. And let's call this the event. And same thing here. If we don't have an event to avoid any runtime problems, we're just going to continue, there we go, and kind of skip to the next iteration of the for loop. Now, inside of here, we need two things. First off, we need the key to actually get the country from it, because this is the object key. To get it, we can say const key is going to be equal to object.keys of the event at the index of 0, and just tell TypeScript, yes, we know this exists, this is fine. And now to get the value, we can say const value is going to be equal to object.values of the event also at the index of 0. And we can also tell TypeScript that, yes, we know this will definitely work. Now, to actually extract the country from the key, we need to parse it. This is a string, and we need to parse this into JSON. Pretty straightforward. Const parsed key is going to be equal to json.parse, and we can parse the key. So now we can access all the metadata, like the page, the country, or whatever custom values you define wherever you track this. If I were to enter the name right here of John, then we would also be accessed the name right here for the parse key, because it is stored in metadata, which is awesome. So to get the country, const country, this is going to be equal to the parsed key dot country. And let's just in case make this optional, because by default this will be typed as any in TypeScript, which is not ideal. And if we have that country, if it is provided, then we can perform an operation on it and add them all together, because it's very possible that across multiple days the same country is going to be appearing. So if the country DE was 5 people on day 1 and kind of like 6 people on day 2, then we are going to iterate over each of these, and of course also for the other countries. But if there is already a 5, then we want to add the 6 to it to have like a complete total for DE, which is Germany, by the way. It's just a country code, oops, DE of 11 at the end, right? This is what we want. So we need to check, is the country already in the map? And if it is, then we're going to add to the previous count. And if it's not in the map, then we're going to initialize it. So with the map, this is super easy. We can say if the top countries map dot has the country, if it's already in there, that means we just want to increment the value. So we need to get the previous value to add to it, right? And the previous value is the top countries map dot get of country. And we can just let TypeScript know, yes, we know this will exist. And the addition is as easy as saying top countries map dot set, and we're gonna say we're gonna increment at the country as the key, and we're gonna say prev value plus the current value of the, like the 5 or the 6 of what we're iterating over. As easy as that. And else, if the country is not in the map yet, in that case, we can simply say top country, countries map dot set the country to the value if it's the first time we're seeing it in the array. And that's how we achieve this kind of sums right here, like the 248, 137. This is across all days, across all events, how many people came from this country. And this right here is how we do it. It's as easy as that. That is our top countries map. And because we only care about like the top 5, we can also say const top countries, countries is going to be equal to an array, because now we want to get only the 5 most views. This is actually not in order right here in the map. Therefore, to order it, it's as easy as spreading in the top countries dot entries and then applying a sort on them. So we can say dot sort, and we know this from before. We get an A and a B right here. So this is going to be each element that we're iterating over in the sort. And we can simply say if the A at the index of 1 is larger than B at the index of 1, in that case, we're going to return -1. So what is A at the index of 1 and B at the index of 1? Well, essentially, it's just the values right here, like the 5, for example, because the entries is going to be, and by the way, we need to fix this error right here with the ES 2015 in the TS config. So as the target, let's say ES 2015 in or tsconfig.json, because that's what TypeScript demands in order for us to use this kind of syntax that makes the sorting really easy. Because the entries is a string number array. So the A at the index of 1 is going to be the number, how many times we had a page view from that country. And we are simply comparing that to the next country and then ordering them. And else we're going to return 1. So what this is going to do is, if we now slice this array from 0 to 5, get the first 5 entries of the array, this is going to be sorted in order of the most kind of visitors from a country to the least visitors from a country. So this is going to contain the most visitors from the 5 or however many you want, 10, 3, whatever countries. And this is already it. We can simply pass this into our analytics dashboard, receive that in our analytics dashboard, and this is going to be of type string, which maps to a number array with a length of 5 or whatever we said. And then we can just render this out beautifully with the country flags, as I showed you. And what this looks like, it will look like this with the country flags. Doing that is surprisingly easy actually, and we're going to do it right above the card where we map over the time series page views. We can simply create a new card, give it a class name of flex, flex-call on small devices a grid calls of 4 and a gap of 6. And inside of this card, we're going to have an h2, a heading element with a class name of width full, a text dark, tremor, content strong, a text center, on small, a text left, a font dash semi bold, and lastly, a text of XL for extra large. And inside of here, let's say this week's top visitors. Great. Now to actually display them, we're going to do that inside of a div, and this is going to get a class name of call span 3, flex items dash center, a justify between, a flex wrap, and a gap of 8. Now we simply need to iterate over the top countries that we can receive as a prop. By the way, in our analytics dashboard, we already defined the type for it. So now we can map over them and just display the countries and their respective view counts. Right, so we can map over this. This is optional, which is more a TypeScript thing than an actual runtime problem. But let's just put a question mark here to handle that case. And we can destructure the country code, and we can destructure the number, which just means how many people visited from that country right away. In here, we're going to return a div element. There we go. And this is going to get a class name. And of course, we also need a closing element with a class name of flex items dash center, a gap of 3, and a text dark, tremor, content strong. Inside of this div, let's create a p tag, and this will get a class name of hidden on small devices block and a text tremor dash content. Inside of here, let's render out the country code. This is gonna be US, DE, FR, and so on. And below this p tag, let's put a React country flag. Where does this come from? That is a package, npm install react country flag. And all that package does is literally map country codes to the SVG of the country. It's as easy as that. So we can simply go to the very top of our file and say import react country flag from react country flag. Perfect. And get started in using it. The usage is super easy. We can pass it a class name, for example, how large we want it to be, like a text of 5XL, and on small devices, a text 3XL. We can pass it the SVG property to render it out as an SVG, and it also needs the country code, and this is nothing else than the country code we destructured right up here from the array. Perfect. And below that, we can also, if we want, put the amount of times that users have visited from this country, which is going to be inside of a p tag with a class name of text tremor content. And on small devices, we're going to apply a text dark tremor content strong. And inside of this p tag, we're going to just put the number, the amount of times people have visited from this country. Perfect. If we save this, again, we won't have this data in local development. We're only going to have it once we deploy it, but I'm going to make sure to deploy this and then, kind of show you what this looks like, just so you know this works. But if we reload our page right now, we should be able to see the section right here, and it will actually fill with data once we get our project up and running in production. Beautiful. There it is. That took a long time to load. My PC is pretty old. But anyways, once we're in production, this will start filling with values. Beautiful. And now we're as good as done. The last very cool detail, admittedly, are these little badges right here on how much the increases. I think that's a really neat detail. It only takes like 1 or 2 minutes to do. So let's quickly go ahead and do that. And that's really going to improve the look and feel of our dashboard. So let's quickly create a component for this. Let's name it const badge inside of our analytics dashboard. By the way, we can close out of all the rest of this. And this badge is going to be an arrow function receiving one thing only, and that is going to be the percentage. And we can inline type this. The percentage is going to be of type number. Now, we can do a check. Const is positive is going to be equal to percentage is larger than 0. Because if it is larger than 0, that's good. We're getting more visitors. That's great. Let's say const is neutral is going to be percentage is triple equal to 0. And of course, the const is negative is going to be percentage is smaller than 0. Now, one little check, if the percentage is not a number, if is nan percentage, in that case, we're just going to return null early. Return null. We don't want to render anything. And this is known as a guard clause. So in the following return statement, we can assume that the percentage is always a number and do calculations with it where we need to know that it is in fact a number. Now, this span element that we're going to create in here is going to get a class name. This is going to be a dynamic class name. So it needs to be in curly braces and with the dynamic syntax right here. This is going to get inline flex, a gap of 1, an items-center, a rounded of MD, medium, padding X of 2, padding Y of 1. We're going to give it a text of XS for extra small, a font dash medium, a ring dash 1, and a ring dash inset. And now comes the dynamic part. Let's define 3 class names. Const, positive, or let's call it positive class name. And this is going to be BG green 900. And then an opacity of 25 separated by a slash right here. This is going to be text green 400 and a ring green of 400 slash for the opacity, once again, 25. And here comes the dynamic part. So inside of the class name, if we have the is positive, then we're going to apply the positive class name. Else, if this is neutral, then we're going to apply the neutral class name, const neutral class name. And this is going to be very similar to the positive class name. We can copy and paste it, in fact, but mark the greens using Control and D to mark multiple occurrences and replace it with zinc. And same thing goes for the const negative class name, just like this. And I capitalized that N. Let's not do that. This is going to be again the same thing, but replace the green with the red. So if we are neutral, in that case, we're going to give it the neutral class name, and else this is negative, so we're going to give it the negative class name. Perfect. And inside of the span, we're going to check if is positive. In that case, we're going to render out a little icon, the arrow icon right here that points to the top. And to do that, we're going to get set up with an icon library, npm install Lucid React. This is a super neat React icon library. That's all it does, but it does that really well. The icons look great. And when that's installed, we can already start writing the arrow up right here. This is going to be from our icon library with a class name. This is going to be height of 3, width of 3. And if we are not positive, then we're going to render out null, just like this. Beautiful. The icon library is done. We can copy this down once and change the is positive to is neutral. And in that case, we're going to render out an arrow right. And once more, if we are negative, if is negative, then we're going to render out an arrow down right and also import that icon. Beautiful. Now, last thing to do is to actually show the percentage, the 66%. Right here or whatever, and this is nothing else than the percentage.toFixed of 0, so we never get 1 after the comma, %. And that's it. We can now use our badge in our code wherever we show the amount of visitors we have, right? So for example, let's do it in the visitors today. We can put our badge component here. This is going to be self-closing, and it takes the percentage, which is the amount of visitors today divided by, as a number, the average visitors per day. Perfect. -1. There we go. And then the entire thing times 100 to get the percentage. If we save that, the thing should appear, the badge should appear. And did we? Yeah, it doesn't because we didn't start back up our dev server. So let's do that. And then we're going to be able to see like a little badge up here. And right now we're above the average visitors per day. So we expect a green icon right here because we're doing pretty well. We're higher than the average. And there we are. How cool is that? 614% above average. Not super accurate. It's technically correct, right? But we didn't track all the previous days, but you know, it's accurate, but it's a bit exaggerated, I guess. Anyways, to kind of separate it from the p tag, we can give the p tag here a flex, a gap of 2.5 and an items center, just to kind of make this look a bit better, where the badge is a bit more separated from the text. And once again, my PC is hella slow. This might take a bit. And there we go. My PC is finally done loading. There it is. Let's open this beauty up. Again, if you wanted more fields up here, I explained exactly what to do. It's the exact same logic where inside of the page.tsx for the analytics, right here, you would simply do the same thing and retrieve the analytics for that particular event, like the exports, as I showed you in the example right here. That's how you do it. And that's as easy as that. We can see the top visitors. We're going to deploy this, and then you're going to see what this looks like. And then for each day, you can see how many visitors you have or how many other events happened. Doesn't matter which kind of event happened on that day. How cool is that? You did a fantastic job following along. I really hope you enjoyed this. And then let's deploy this to Vercel. And I'm going to give you a little quick preview of what it looks like with the country visitors. So the deployment process into the side project is really easy. First off, we create a new GitHub repository. We push our local changes into that GitHub repository and simply hit deploy. There's almost nothing we need to configure. Don't forget the Redis key environment variable wherever you deploy. For example, Vercel, there's so many other places like Railway, DigitalOcean, Fly.io, so many other places where you can deploy Next.js. Vercel is probably the easiest for now, and especially for beginners, right? If you're a beginner, just go with Vercel. It's super straightforward. Just hit the big deploy button, enter your environment variable, and there you go. It's working in production. It will actually provide you with the countries in the middleware that we use to track and display in our dashboard. I really hope you enjoyed this video and get a lot of use out of it to optimize your website, to learn how to write clean APIs, and I just genuinely hope you enjoyed following along as much as I did creating this project and then sharing it with you right here. So once again, thanks for this, by the way. This is pretty neat, and I'm gonna see you in the next video. Have a good one. That was it for today. Until the next video, have a good one, and bye-bye.